Okay, guess we're good to go. We are 3 minutes over anyway. So yeah, hi, welcome everyone. Welcome to today's Tech Talk in the format of Mirantis Labs about exploring Kubernetes observability with OpenTelemetry. My name is Martin Nirtl. I work as a solutions architect at Mirantis. I'm an IT engineer with strong backgrounds in software and DevOps platform engineering. You can find me on LinkedIn, Twitter, pretty much everywhere, also on GitHub. If you're curious to check out the code that I produce in my free time. Let's talk about what we are going to explore today. So today we are going to talk about observability. I will give you a short introduction into observability. It will be pretty much holistic, I guess. Then we talk about the OpenTelemetry project, how it fits into observability generally, and what you can expect from it. Later on, we'll have 2 demos, mostly about tracing, so that you get an imagination how tracing looks, where the data comes from, and what you can maybe do with it. And also I will mention Kubernetes components tracing, which is fairly new, just entered beta with 1.27 version of Kubernetes. So I will also show that. So if you're curious on that, we will handle that as well rather at the end. And with that, we start with a little poem written by ChatGPT on observability. I'll read it aloud so you can enjoy my beautiful voice and also the nice poem from ChatGPT. So here we go. Observability, don't you see, is about understanding the system's degree. Through its external outputs and behaviors, it provides insights for troubleshooters and bearers. Collecting data from various sources is the key to gain insights into performance, health, and reliability. Observability is crucial for efficient monitoring and optimization of systems that need fine-tuning. So if you want to keep your systems running right, observability should be in your monitoring site. So that was what ChatGPT had to say about the topic. Of course, that is not the intro that I meant earlier. That is really only something that should put a smile on your face. As for me, it's already pretty late and the end of my workday nearly. So yeah, bit fun is definitely not wrong, I guess. So let's now really talk about observability, and I will try to make this quick, like 5-minute intro, maximum 6. Let's try. Yeah, why do we need observability and what is it roughly, right? So today, modern applications are built and deployed as microservices and distributed systems. Of course, in the early days, we had monolith and stuff, but this is really not why we need observability so drastically. So let's continue with my example. We just imagine we have a web shop that, for example, is horizontally scaled and uses a microservice architecture pattern. It runs on top of Kubernetes, has, for example, a load balancer in front and receives traffic. And of course, we want to ensure that our software is working as intended. And that is exactly why we need observability. Observability lets us understand if our application or whatever we are operating is in a healthy state and working as intended. So now let's, for example, assume that not everything is working as intended, right? This is unfortunately the case. Our software doesn't always work perfectly. We have bugs, we have issues with networking and stuff. So we need to somehow learn about it. And this is where observability kicks in. So let's assume now we have a problem, and how could we potentially learn about it? So what is observability actually? So well, observability could be, for example, logs. In our logs of our load balancer, of our ingress gateway, for example, of any our service logs, we can find the issues there. We can have central logging. Maybe we don't have a sophisticated central logging solution, like, for example, the Elk stack, pretty famous, or Loki from Grafana. If you don't have central logging in place, you would need to check, for example, the logs via kubectl, also doable. So what else is there if we want to get to learn about the problems? We could have metrics, right? Metrics like error rate would directly indicate when error rate goes up. We would directly see that our latest release of a checkout service, for example, has problems. Now, only with that, we wouldn't directly see what exactly is the problem. So you see already metrics are on a higher level, while the logs are on a deeper level. The logs typically are the most detailed information that we could get, as they are written typically by the developer himself. And in between, we have traces. And traces show us timing information, kind of a calling tree, as you can imagine, in the backend of our microservice architecture. So we see how a request, for example, hitting the load balancer and then traversing through the backend, we can really see and understand on how it's processed in the backend, even though it's maybe processed by multiple stages and multiple tiers in the backend. And yeah, here you can see, for example, a really simple span, which has a root span or a trace, a client span, which is then really reflecting the timing information on the client side, going via the load balancer, ingress controller, front-end service, and so on. And these are the means. Now we won't solve the problem really what the client faces in that situation. I guess for that we have too little information, but these are the means that we have and that we address to when we talk about observability, at least when you Google for it. So when you Google observability, what you'll find is mostly the pillars of observability. So to keep your mental model, I've also put real pillars on the right. And the pillars are metrics, traces, and logs. Metrics, as already mentioned, could be failure rate indication, could be, for example, CPU utilization. If you have a Windows PC, Task Manager, open it, you can see metrics there, like CPU memory utilization. Logs, as said, like pretty much every application, hopefully, on this planet writes logs so that we at least have some indication when something is behaving oddly. And traces, as said, very important for distributed systems to understand sequential order of events, but also timing information and everything around timing, basically. Now, is that everything for observability? Not really. There can also be, for example, topology information that can be sometimes be extracted from those pillars, but can also come from other systems like service meshes, for example. And additionally, you could, for example, also have profiling data. Very important if you do or are in the APM space and want to do some performance engineering. Make your latest Rust app even faster. And it's already faster than Light. I don't know what you build in your free time. So yeah, these are the pillars, and they are created and produced by your app. So every app, every tier in your backend produces metrics, traces, and logs. Of course, everything is optional. Typically, you always have logs, and metrics or traces are really like kind of an add-on. At least this is what we see out there nowadays, mostly. In best situation, everything is available, so your app produces all of them. Now, should there be a relation between those signals or between those pillars? I would assume so. And the reason for that is coming now. So when your application emits those signals of metrics, traces, and logs, you should add metadata to it or labels, something that really ties them together so that you then later can really utilize them together when, for example, you identify that there is something odd, like failure rate increase, for example, on the metrics. You could then switch over to traces or to the logs. And this is exactly what the intersection of those circles should display. This is really where you can then utilize the labels and metadata that you attach to your telemetry data to really gain kind of a context. And that context you can then use for really switching between the trace view, the logs, and the metrics in order to understand a certain problem. To outline that a bit better so that you really understand what I mean by that by that context is, for example, my context is that I look at the screen and I see, like my Grafana dashboard, for example, I see that for 95% of the time of a certain endpoint, I see 8.5 seconds per request spent as a response time metric. And I want to dig deeper, I want to understand why this is the case, but only by looking at that metric, I won't understand it. So I tell it, show me the related traces. And because we have that context, because we have that metadata attached to our signals, to our pillars, we can switch over to only that 5% above the 95th percentile. And when I see the traces, I can analyze timing information. And most probably there, I will already get a gut feeling about what's running or what service is causing the delay. And then if I really want to have a deep understanding of what exactly is happening in my application, I most probably will find this in the logs. So I can, for example, have a look in the related logs and understand how or why I see that increased response time. Now, can I do alerting or should I do alerting there? Yes, definitely, because of course we are not paid to look on a dashboard every day, all night long, not really. So you can have, for example, metric-based alerting on the metric level, obviously, and this is definitely more generic and high level than, for example, log-based alerting, which is typically more detailed and really hard to maintain just because of the level of customization that you need to do in order to have proper alerting setup on the level of logs. Nonetheless, of course, maybe I'm wrong, right? There are companies like Splunk that do a fantastic job all around logs. Now, today's superstar is tracing. So from now on, we will more focus on tracing and OpenTelemetry. And yeah, really briefly, what is tracing? Again, it shows an order and timing information of everything that really happens in your backend. Traces are emitted per service as for metrics and logs. So this is really nothing new. They have a relationship between each other, hopefully, so that you can really utilize them to the fullest potential. What you do with tracing is typically troubleshooting and performance engineering, because you have the timing information. You see where you have the bottlenecks in your application and improve there. Of course, if it's about timing, also I would say always profiling is pretty important, because in profiling you also see where really the time is spent in the code. So this goes side by side. And tracing is also, or can be also, a basis for metric calculation. So you can, for example, calculate 3 out of the 4 golden signals by the SRE Google book, if you know that. You can compute them from traces. Like, for example, if you just imagine timing information, you can easily calculate the response time metric from the timing information that a span carries. Spans also carry, or spans or traces, sorry for the interchangeable usage here. Traces also carry information about success of an execution, so you can also calculate error rates. And of course, traces also carry some information about the requests per second, about the traffic, and this is also a golden signal. Tracing was also the initial focus of OpenTelemetry, and yeah, tracing works with context propagation. So easily said, IDs that get passed along each backend tier in order to create a meaningful trace. And what do I mean by that? So what is a trace, and how does this really work? So a trace is really a sum of spans, like 3 spans in our case, and this is then a trace. This forms a trace, and every span gets emitted, as you can see here in the colorful image. It gets emitted by a service, for example. And front-end service creates the root span or trace. It passes on the context when it calls the checkout service. So it really calls the checkout service, and what automatically gets passed along is the so-called trace context, which carries the information of where the telemetry data should go then in the end, or how it should be stitched together. So we need some kind of thing that we take to tie that spans together. And the same goes then for the card service. And as said, there is the trace context automatically passed along, and trace context is trace ID plus span ID. And trace ID is really the thing that groups the trace, and the span ID is what the information about that span that the service emits. Yeah, and that's it. That was the introduction to observability. Let's now talk about OpenTelemetry, the ring to rule them all, at least from developer perspective, and how to generate telemetry data. So where does OpenTelemetry fit into the picture? Well, when we look at the pipeline on this slide, we see that typically you start instrumenting your application. You then instrumenting means you emit the signals like metrics, traces, and logs. You can collect them. You then store them somewhere, and then you visualize them in order to make use of them. OpenTelemetry actually tackles the first 2 parts of that pipeline, which is all about instrumentation and collecting. And storing, you would need to do, or you would need to use something else like Grafana, for example, as I've indicated here, because we will also see that later in the demo. The OpenTelemetry project itself is open source and is vendor neutral, which is super important because you don't really want to have custom instrumentation in your code that is maybe dependent on some proprietary vendor or whatever. OpenTelemetry is a collection of tools, APIs, and SDKs. As you can see on the right in the image, you have, for example, your app code, and there you use SDKs and APIs in order to generate metrics, traces, and logs. At the moment, only traces and metrics can be considered stable from a specification standpoint. Logs are difficult to handle because of their legacy payload, I would say. If you want to go into detail about the logs and why it's not stable yet, we can talk about that later if you like. Just put a question around it in the Q&A, and I'm happy to talk about it as well. Yeah, OpenTelemetry project handles everything around instrumentation, generation, collection, and exporting of telemetry data. As you can see here, we have the OTLP protocol in the image. I don't know if you see my mouse. I hope so, because I move it all the time. So we have the OTLP protocol that is being used for sending and transmitting telemetry data. We have the OTel collector. OTel is short for OpenTelemetry. Collector that is kind of a gateway component and then distributes all your signals to the right backends like Grafana. I don't know if you use Dynatrace, for example, or AppDynamics, whatever you use, Datadog. Yeah, everything possible. And OTel collector pretty much supports lots of different protocols, not only OTLP. OpenTelemetry is a merger of OpenTracing and OpenCensus, and maybe more interesting, it has a huge community behind. It's the second most active project after Kubernetes on CNCF, and it's an incubating project there. Yeah, and that's it. Let's now talk about the demos, or look at the demos. So we have two, I said I have two demos prepared for today. One about tracing with the OpenTelemetry demo. OpenTelemetry demo is now not my weird title about this. OpenTelemetry demo is really something that is built and produced by the OpenTelemetry maintainers themselves in order to have a proper demo to demonstrate the abilities of OpenTelemetry. That was a lot of OpenTelemetry, but that's how it is. Sorry for that. So what is exactly this OpenTelemetry demo? I will also show quickly then later the link and where this is hosted. So if you want to check that out, you can also find it on the internet. For now, let's quickly have a look on the application architecture. So you see, for example, this is really a distributed system. It has a front-end proxy, front-end service, then recommendation service, many services. Easily said, or simple said, it's a web shop. It has also Kafka in it, Redis cache, whatever you can imagine. It has state, it has everything really. It works a lot with HTTP and gRPC, like the most commonly used backend protocols that you can imagine. And on the bottom, if you care for technology support, you see all the different languages being used in that application. So you can, I think, pretty much find everything there. About the setup, how do I host this today? Well, this runs in a Kubernetes cluster. The cluster is a K0s cluster via Lens. Lens IDE, maybe you know it. It's a fantastic tool for operations people, but also developers that want to play with a Kubernetes cluster. You can easily start it and then inspect your cluster with the power of Lens IDE. The OpenTelemetry demo is deployed via Helm. I use the OpenTelemetry collector that is managed by the OTel operator. Yes, there is also a Kubernetes operator that manages the OpenTelemetry components in the cluster. And as an observability platform of choice for this time, I've used Grafana Cloud. And with that said, let's quickly have a look on where this comes from and how it's installed, and then we check out the traces. So traces, step back. How to deploy this? This is really super simple. It's basically only two commands. Like first you add the Helm repository and then you install it with the default values, and then you're already good to go. You will see the application, the demo application up and running. You get your own fully fledged Grafana installation, meaning I think Jaeger as tracing backend, Grafana for the visualization, and then it will exactly look as my setup today. So really simple, and I want to keep this really short because you can, of course, check this out on your own as well. This is on opentelemetry.io under the demo part. Now, for the setup, what I've prepared is really only Grafana, pair. So no dashboards, nothing. So we will mostly go with the Explore feature today. And here I have already prepared a trace that I found interesting, and I really want to use that today to explain to you what is a trace, how to read the trace, what information we find in the trace, and maybe what we can do with it. So here you see such a trace. On the top, really, you see that the root span, so the parent span of all the spans below is typically also referred to as root span. We can click it, of course, to get more details. Of course, now what you see, this is not really specific to Grafana, but typically you find every kind of feature that I show now in all of the tools out there. We can see attributes, so we can see metadata information attached to that span. And of course, we see the timing information. Now, how to read the timing information? You see on the left, you have the tree. So always you have a parent span and then a subspan, a child span. And the subspan is always a child. So this runs within the parent span, if that makes sense to you. You see this is still in checkout service. And this is kind of a calling chain. This is how I would at least always see it. Some of them are running, or some of the steps are running in sequence, as you can see here, for example, like the checkout service get cart, and then here the product catalog service get product. This is running in sequence, and this is how you should actually read it. So from timing information, this goes really down and further down, like this kind of waterfall. Now, I want to also send you or show you some information on what you can actually find in such spans. So it's really useful for developers, really, because they write the code, right? And they should be also in the position on writing that metadata or attaching that metadata that they later on need for troubleshooting, for example. As an example, maybe as a bad example, I've chosen this email service now, send email, where we can inspect the attributes. And what we can find there, for example, is really custom attributes. The developer himself is in the position to add that information, and he can, for example, add the recipient of that email. Now, is that a good idea? Not really, because PII information should be treated carefully. And Tobias at example.com, he won't be happy to see his email here today. Now, this should definitely not be done, but of course, you can add also meaningful information there, right? And let's now quickly check if I can find something meaningful here. For example, like shipping cost total. So really not PII relevant information that helps you in debugging. For example, when you need to have the shipping cost that you want to then, for example, convert into a certain currency, that could be useful information that should go there. Also, you will always find information about whether it was successful or not, like the status code 0 stands for success. How does this really quickly look from an instrumentation standpoint, if that's interesting to you? I have now picked this send email example that I've shown you, where we added the email from Tobias. Now, this is exactly the code snippet. I hope it's not too hard to read. I want to highlight this section here. So we see here is where the span really starts, send email. This was also the name that we've seen in the UI. And here, span set attribute, we add the email to that. So it's really as simple as writing logs. And what you get is then all the timing information plus log information on top. So is it worth it? I think yes. And also I want to mention the possibility of auto instrumentation with OpenTelemetry with certain libraries. So then you don't even need to touch the code, and you can hook the auto instrumentation automatically into your application. Yeah, to also have an example of what can go wrong. Of course, in your Grafana backend, you can always search for example, spans that have an error state. So this is what I've done here. And then you can inspect the trace. So how does it look, for example, when something is auto and there is erroneous behavior in your application? Well, you can, for example, directly see it with this red circle with an exclamation mark in it. And we see here it on the front end, so it really bubbled up and it originated from the product catalog service. So there is something running odd, and this is because OpenTelemetry also has certain capabilities in simulating problems. And in this case, the product with that product ID is not available. And that's why it came to an error. And this is just for really demonstrating on how errors are indicated in traces and how you can find them then really easily by, as said, simply filtering for the status code, and then you can also already start your troubleshooting. Of course, if you, for example, are responsible for a certain service, you can, for example, first filter for it and then check the spans for the ad service, for example. Now, as we are already coming to the end, now let's really briefly only touch the tracing for Kubernetes components, which went beta in version 1.27. It only supports export via gRPC for the Kubernetes components like API 7 kubelet. But if you're using Containerd underneath, you can also use gRPC there. And I was pretty curious on how this looks really and what I can do with it. For the use cases that I found is really you could, for example, track or debug webhook issues if you build your own operator, for example. On the kubelet level, you can track garbage collection, or trace garbage collection and the pod sync routine, if that's interesting to you. I actually did never see it, so I was really curious in making that work. And of course, you can also check out Containerd, especially in combination with kubelet, because then you will see the traces. Now, the bummer of the story is really that it doesn't give you much information. Tracing, how it's done in Kubernetes currently, it doesn't have too much information. This is, for example, the trace that you get when you deploy a deployment in Kubernetes. And when you, for example, check it, you don't get more than the name, which is fine. Again, here's actually the name, which is fine, I think, for Kubernetes, but I was actually expecting a bit more. So yeah, same goes for kubelet. I was also expecting like kind of an end-to-end trace right when a pod gets scheduled, but that was kind of a bummer for me. But nonetheless, this was super interesting exercise. And yeah, if you're curious on the files or the code or everything that I've used today for visualizing those traces, please reach out to me or tell me now and put your email in the chat, and I will follow up with the information and with the files because they will be hosted on GitHub by the end of the week. And with that, I think we can do the Q&A now. Do we still need to update our code intrusive in order to get distributed traces with OpenTelemetry? No, you don't need to. Typically, this depends on the language itself. Like, for example, Java is a super language where you can hook in so-called agents into the application itself, and it auto-instruments it. This naturally comes from the technology behind Java runs sandbox in kind of AVM, and there this really works seamlessly. Also in JavaScript, and this is really where I have the practical know-how. So you can just hook it in by providing a file, and it will then auto-instrument everything for you. So no intrusive actions, no manual instrumentation. It works automatically, as said, but this depends on the technology. So please, if you are curious, we can have a talk afterwards. You can ping me on Twitter, I guess. Also, maybe quickly, where to get started? Where would you find such information? Well, it's actually on OpenTelemetry. If you go here under instrumentation, you see what languages are at the moment supported, what stage traces are, metrics and logs. And if you, for example, want to check out JavaScript, you can go there. You can go to Getting Started, Node.js. And let me check if there is also auto-instrumentation. Yeah, there is even auto-instrumentation handled for Node.js, for example. So you should find the information there. Okay, next one. How can we correlate trace logs metrics with OpenTelemetry? It looks like OpenTelemetry is about observed data collection, but not really about the access of this data. Do we need to use specific product to visualize and correlate these observed data sources? Yes and no. So let's start with how can we correlate trace log metrics with OpenTelemetry? So OpenTelemetry is really about emitting the signals, like creating instrumentation, collecting it, and exporting it to your observability backend. You need to put the information that can be used for that correlation that is needed to bring them together in the backend. You need to put that metadata to your signals. So when you write your trace, it will have the trace ID and the span ID, right? So this is the fundamental part. Then when you write, for example, a metric point, you could add for the metric also the trace ID. Same goes for the logs. If you have structured logging, meaning JSON, for example, you should put the trace ID there, and then the trace ID can be used as a mean to correlate all the three signals and have that kind of context that I was talking earlier about. In Grafana, for example, this is relatively simple. They really use the trace ID for doing that correlation. Other systems, like for example Dynatrace, they also use the trace ID, but there it works kind of more proprietary because Dynatrace is a proprietary product. If you wonder why I'm now mentioning Dynatrace, I was working for Dynatrace before. That's why I know how it simply works there. Nonetheless, I would say every modern provider has the abilities to provide that feature to you, but as said, there must be some kind of metadata attached to the trace, to the log, and to the metric point in order to correlate it. What about trace data collection from the service mesh layer? Can we feed the observed data from service mesh back into OpenTelemetry? So when you check, for example, I will now refer to I think actually like Google Service Mesh Istio and also Service Mesh Linkerd, they emit already traces as well, and of course metrics. You can feed them into your observability backend also via the OpenTelemetry collector. Can we get traces for the inner workings of services without intrusive code addition? What is the performance overhead for trace collection? Really good question. So before I was mentioning service mesh. For service mesh, you can only get the outside traces. So the services will be treated as a black box. Still, you will have the golden metrics from it or golden signals from it, like response time, traffic, and others. But for the tracing, you will only see the outer timings. That's maybe enough for you if you have super good logging in place and you can isolate problems to the service level, and from there you directly jump into the logs where that's fine. However, I would say with the capabilities of OpenTelemetry, it has auto instrumentation capabilities, so you don't need to touch the code and add it manually. So with that, I would say it's a low-hanging fruit, of course, as with any observability mechanism, like metric, whether you write metrics, traces, or logs, also logs add overhead. When you write a log in your application, it is overhead, right? It's not business logic, it's writing information to the disk. And this will be overhead. Now, what is the overhead of tracing? That depends on how many traces you actually write. Unfortunately, I can only give you the famous answer of it depends. But this is definitely testable. So you can, of course, if you run your tests, you can observe it. You can also apply sampling. So you only, for example, send and send samples so it at least is lean over the network, and you don't waste too much network on sending those telemetry data over to your observability backend. Can we trigger distributed tracing or change the sampling rate on demand on the fly with OpenTelemetry? Now, with OpenTelemetry itself, I don't think that this is at the moment covered. There is something that is called OPAMP. And with that, I think you can dynamically, or this is actually the protocol that is meant to be used for dynamic on-the-fly configuration changes for monitoring systems. So what's the use case behind? And I think this is, again, a very, very good question. The use case behind this, let's say you have a metric that indicates the error rate, and the error rate goes up. And to be lean on storage, but also on the network, right, you write only warning logs or info logs typically. Now, to empower your developers to quickly fix something, you maybe, just for the time when this error rate goes up, want to change log level to debug so that your application running in production also emits debug logs or even trace logs or silly logs, however you name the log level down. Like they get very verbose, right? So that the reproduction of an issue becomes easier for the developer. And this can be done by protocols like OPNP. And that's in the makings. I think we are still in the very early days of it, but I think this is really great stuff to come. And I'm looking forward to seeing that emerge and to use it also, because I think this really reduces a lot of cost, especially in the clouds, because telemetry data is not cheap. Yes, I just got the answer about updates in the code. How does auto instrumentation work? Is it an agent running in the JVM for Java and so on with other programming languages? Do we do to attach such auto agent for each programming languages? Can these agents be ingested through Sidecar and K8s mutating webhook? Yes, this can be done by Kubernetes mutating webhook. I think I mentioned this shortly. So there is actually an operator for OpenTelemetry. It automatically injects the configuration that you would need there in order to make the auto instrumentation happening. Now you see that I think these are only the languages or the technologies that are currently supported, like .NET, Java, Node.js, and Python. This is, for example, how it looks for Node.js. You would need to add a CRD instrumentation and to specify the endpoint, the propagators, how it works, and the sampler. You can also configure it from there. So really nice. I guess then it hooks the auto instrumentation things automatically into your application if it runs in Kubernetes with that Kubernetes operator. I've never tried that one so far for the auto instrumentation point. Is there a guide to get started with instrumentation? Yes. So right here on the screen, you see, for example, all the technologies that are being supported. So if you, for example, are curious around Java, you just go there, you can do the getting started section. I would advise you to really start with the getting started and then dig deeper, for example, and understand how the automatic configuration and instrumentation works. And for the Java question before, as you can see here, Java, I said, like it really has, from a language perspective, this Java agent flag where you really hook in the path, like your Java agent from OpenTelemetry, and then you get the auto instrumentation from that. But as you can imagine, not every language has a Java agent or an agent flag generally to load an agent. So this is maybe only a specific thing to Java, but for sure not for Node.js, for example. What's the relationship between OpenTelemetry and Kubernetes Tracing components? In the last slide, API server, kubelet, and containerd. Well, the relation is actually that Kubernetes introduced tracing support for some of its components. If we quickly go to Kubernetes Tracing components. So if you may know, and before I continue to speak, I need to open it because I'm not really a multitasker. So that's the page actually. So traces for Kubernetes system components. So with 1.25, I think Kubernetes introduced tracing support for some of its components in alpha stage. Now they're on beta, and you can configure the Kubernetes control plane itself. Like you can treat it as an application to emit traces. For example, certain actions, like when it receives a deployment to deploy, right? So this kind of stuff you can then trace. I've mentioned this, maybe it wasn't clear enough from my presentation. I was doing this explorative. I wanted to figure out on what information I get. For me, this was kind of a bummer because I was expecting actually more information from it. It's pretty limited so far. I hope this becomes better. For now, if you, for example, monitor your control plane, I would rather really keep it with log monitoring, audit logging and stuff to be aware of outages. Also, like the metrics, I think are already great, especially with projects like Kubernetes. This does a fantastic job on the control plane monitoring. So I would rather stick with that. And for now, not add tracing to not bring tracing to the table. I think this doesn't pay off for the time being. But of course, if you want to play with it, like feel free. It's documented in detail on that page. Really, I can also put it in the chat maybe if you want to have that link. Should have done that maybe earlier as well. It's documented really nicely. Just one thing, of course, if you export the traces, you need to make sure that the receiving component that receives the trace, like your OTel collector, OpenTelemetry collector, for example, it needs to run on the host network most probably, because Kubernetes is running not within Kubernetes. And yeah, with that, I think we are good to close the session. So I hope it was interesting for everybody. I hope you learned something today. I hope I could grow some interest in you. So yeah, with that said, thanks for joining and have a great day, everyone. Bye.